These problems on the coding system will be part of the assignment 3. So assignment 3, section 1.2 problems for assignment 3 will be 18, 20, 22. 18, 20, and 22. And I will be, when I create that link for the assignment, that link will tell you exactly what problems are due in that assignment. So let me show you that one more time. Where's that? Okay. On Blackboard, if I go to the submit assignments, see, homework assignment 2 tells you exercise 1.2, these problems will be the problems. So in the same way, for exercise 3, homework 3 also, I will be telling you exactly which problems are due. So this is the most accurate information about the assignment. The course calendar, we may have to go off the course calendar sometimes. It all depends on how many questions you ask and I have to answer. And, sometimes we had to slow down, sometimes we can speed up. So it's kind of hard to follow the course guides all the time. So this will be always accurate. 1 second. Okay. All right. So going back to the presentation. So we finished section 1.2. So going on to 1.3, the programming languages and compilers. Now, before that, before I start, I have already graded your assignment 1, and I send you a message asking you to review your assignment 1 and look at the feedbacks and have any questions ready for today. So is there any question? Anybody has any question on the assignment 1? Okay. And when you look at your assignment 1 at this time, after I grade it, you should be able to see details as to why you lost points, if you lost points, exactly which problem is wrong and why it's wrong. All those I write on them, and you should be able to see those feedbacks. And if you're not seeing them, then there's some problem with the loading, and you need to tell me so that I can reload it for you and make sure it'll show up on your end.
Professor, I don't think I can't see my feedback.
Okay. Let me go and take a look. If you don't mind me opening it here, I'll open it up here.
Okay.
All right. It's assignment 1, and this is section 2. Let me go over there. Okay. What's your name?
Benjamin Chen.
Last name Chen.
Yes.
Okay. Yeah, right here. I see that you have 100% grade, and so let me open it up. Oh, yeah, there are no feedbacks because, see, there's one feedback here. I crossed out a line and I wrote my own statement as to how it should say.
Oh,
You're
okay.
not able to see that?
Yeah, I see it now.
You see it? Okay. Yeah, if it doesn't, if you cannot see, sometimes I have to open it up one more time, then you'll be able to see. I don't know, for some reason it happens that way. If I
Oh.
reload it, then you'll be able to see it. So if any one of you have trouble seeing your feedbacks, then just send me an email message. I just have to reload it, then you'll be able to see it. So Now, in this case, I didn't write much because you had all the answers correctly done. So I can open another one up if anybody is willing to volunteer. All right, I don't want to open anymore. But usually, let me open another 100% one. Hopefully, he doesn't mind. Often I give you details as to what the grades are. For each problem, how many points were assigned, and then I tell you which problems are wrong, and then I give you right answer in most of the cases. All that will be there, and you should be able to see that. If you're not seeing it, always send me an email message asking me to reload it. All right, so let me go on to, let me close this and go on to the 1.3. And if you have questions, if you're not, after you read my feedback, you still don't understand why your problem was wrong, you can bring up your question for discussion, and I'll be happy to explain to you. All right, so now we are doing 1.3, programming languages and compilers. Computer program has to be in machine language. As I explained earlier, the machine language is the only language computer understands. So the data have to be converted to machine language. The programs also have to be written in machine language for the system to understand. So the original programmers, when the computer was first invented, back in 1950, the programmers had to write programs in machine language. Now, machine language means, everything is coded in with 0 and 1. So imagine a computer program written in machine language. So I'm going to just write what it looks like if you write a program in computer language. It's going to look like this, a bunch of ones and zeros, because that's what the language characters are. So here I'm writing just 2 lines of code in machine language, a program in machine language, but a program usually is pages and pages long. So imagine 5 pages long document having all these ones and zeros. And the real bad thing that the programmers faced was the program is not always right the first time. Programmers are humans. Humans always make errors, and programs you never get it right the first time. So there is always a mistake, and then so they have to go back and figure out the mistake. Imagine going back to a document like this with a bunch of zeros and ones all over and figuring out where the mistake was. That was extremely difficult. So the programmers had a hard time writing programs. So the computer invented at the time, the very first computer builder, IBM, was the one that was facing all these problems. They started, I believe I explained in the last class that the very first computer was built by 2 professors at University of Pennsylvania. And so right after they designed this computer, they decided to start their own business. And they started the IBM company. That was the very first company that sold computers. And the computers were not selling very much because there were no programs available. And the programs were extremely difficult to write because of this machine language. So they had to come up with a solution for this problem. So they were able to come up with a solution. It's impossible to work with the machine language. So they decided to come up with another language, which will be easy to work with. So a language that can be easier for humans to write program in, and that's what a programming language would be. Programming languages are also called high-level languages. These are languages that have English words and math symbols and all those. So for adding two numbers, you use the plus symbol like you always use. And you use English words and things like that in the programming languages. So they were able to design a programming language. That's not difficult, you know. So they designed the programming language. I had to explain how exactly the programming language can be used in a minute, but let's understand these languages. The very first language they designed was called Fortran. Uh, it stands for the words formula translation. Essentially, it's designed to work well for the scientific computer programming, and that's why it's called formula translation. So it worked well, and later other languages came along. Basic claimed to be better than Fortran because it's useful for business purposes. Uh, then Pascal, COBOL, C. The C language was um, there for a while. Pascal and COBOL also lasted a little while, but then after C became popular, those languages went away. And C lasted for a long time. And then C++ is just an improvement of C, which to the original language C, there was object-oriented programming was added, modern idea. It's that object-oriented programming idea that has led to this Windows programming, you know, where you can use icon and menus and all that. That became possible only after the object-oriented programming idea was incorporated in the programming languages. And you will be learning object-oriented programming in 272. Those who are going on to the second course will be learning that. So that was added to C to make it C++. So C++ is a larger version of C. And C++ became the most popular language. And now, even today, that is still the most popular ones. And there are other ones out there, Modular, Ada, and Java, all those. The Java is also getting some popularity, but C++ is still the most used computer programming language. Okay, so anyway, these are the languages, and how do they work? I mean, none of these languages can be understood by the system. So you write the program in these languages, but they cannot be understood by the computer. So what do we do? This is the idea the IBM came up with. IBM came up with the idea of creating a language and then creating another software, a program that can translate programs written in these high-level languages to machine language. See, that's not impossible because in these languages, every word is going to have one meaning. You know, only then it's good for a computer program. And every symbol, for example, if I'm writing plus symbol in my program for addition, the computer program, there can be a computer program that can translate that to the whatever the machine code is. So wherever the plus symbol is in my program, it can write that machine code, the machine language code for plus. So translating by using a software, a program, is possible because every word has unique meaning. So there's a unique code corresponding to everything we write in the program in the high-level language. So therefore, for each high-level language, they were able to design a program that can do the translating of programs written in that language to machine language. So these translating programs are called compilers. So a compiler is basically a program that can translate a program written in high-level language to one in machine language. So here is, so we'll get to more details about that in a minute. So my next question is, why not English? Why can't we write programs in English? The problem is English has its own, not only English, all natural languages have these ambiguities. Words have different meanings depending on the sentence sometimes. And also to have the same meaning, there are multiple words, multiple words to give you the same meaning. So all that cannot be allowed in a computer programming language, and that's a compiler cannot be designed. If you write a program, if you want to write a program in English, there's no way of designing a compiler for it because the words don't have unique meaning. So they selected words from English with unique meaning and created this programming language. And so the compiler, as long as you can design a compiler, you can design your own language. So the program written in machine language, the program written in programming language will be translated by the compiler. So here is a full explanation of that. C++ compiler is a computer program which, when executed, takes a program written in C++ as input. So this program will take C++ program as input and write the same program in machine language as output. So it will translate the program into machine language and it'll give you that as an output in a file. So the translated program will be in a file, in a separate file. So you wrote the program in another file, and now you access compiler will translate it and put the machine code in another file. So your program is called source code, the original program you wrote, and the translated version will be called machine code. So the machine code will be in another file, and that file will be there wherever you stored the original file. In the same place, this file will be there. And when you say execute my program, it'll actually execute the machine code version of it. Your original code cannot be executed. It's the machine code will be executed. And it will produce the results that'll show up on the screen. So every time you write computer program, you need to write it in one of the high-level languages. In our case, it will be C++. And then we have to access C++ compiler to translate that to machine language. So after that, we'll be able to execute it. So when you actually write a program and run it, you have to go through this process. So to execute a program, you have to write the program and type it. To type it, you can use any editor, but if you're using a compiler software, the compiler softwares usually come with an editor of their own. So whatever the compiler you're using will allow you to type the program right there within the compiler. So you type the program and then you say, compile this by using a command. Then it'll compile the program. And then during compilation, there will be errors. If there are errors in your program, the compiler can find certain errors. What errors can the compiler find? Compiler is translating your program. So only if your program is correctly written within the syntax rules of the language, then it will be able to translate it. So if there is something that is not C++, it will complain because it cannot translate that. So if you violate the language rules, the compiler can pick up on those. But if your program is completely wrong, logically wrong, and it's using some wrong method to find an answer, compiler cannot detect that. So if your program is completely wrong, compiler cannot detect that. But if there are language errors, compiler can detect that. One second, someone just came along. Here, see. Okay. So when you are compiling, the compiler will say, there's an error here, there's an error here, which means language error. And you will have to first figure out where they are. It'll give you some hint as to where it is. And Using that, you have to find the error and correct it. And after correcting it, you have to save it. Only the saved file can be compiled. If you remember, I explained in the last class, if you're looking at a file on your screen, the one you're looking at is the one that is in the RAM, the copy that is in the RAM. It's not the copy that is saved on the disk. So what is in the RAM cannot be compiled. It can only compile what you have saved on your disk or hard disk. So your program must be saved first, and then you can compile it. If you make a change, then you have to save the changes, then compile. So you find the error, correct it, make the change, and then save it, and then compile again. So you'll be compiling over and over until you get the syntax errors sorted out. And finally, if it compiles, that means the problems have been solved. I mean, all the errors have been corrected. So it compiles means it's going to create this machine code in another file. And it won't allow you to open that file because there's no point. You wouldn't understand it anyway. So you will be able to execute it now. So if you just say execute my file, then it'll execute the machine code and produce the answer. That's how the program compiling and executing will be. And we will be doing this in class, in the next class. So right now, I'm using a Mac. There is a compiler. There's only one compiler available for Mac, and that's called Xcode. And if you're a Mac user, you want to use Mac to do the programming. The Xcode is the only one. You can use that. The Mac comes with it, so you don't have to download or pay for anything. You can use that. But most people use Windows, and therefore I'm going to show you how to run a program, how to compile and run a program by doing it on a Windows computer. For Windows, there are many compilers available. Most of them are free. So I'm going to explain to you how to use one of those free ones. And these free ones have been adapted by by John Jay. And in all the labs, we have that software already installed. And so it's called Dev C++, DV C++. If you want to download and have it ready in your computer, you can do that. It's a free download. So the full name is Bloodshed Devil C++. I don't know why they decided to give it, scary name, but it is that is the actual name. Abbreviated name is Dev C++. So if you're searching for it on the Google, if you just type Dev C++, that should work. It should find it. You can download it from the first site that shows that this is available, and have it available in your computer. I'll be explaining how to use it in the next class, and we'll be running a program during class, and after that you'll be assigned a programming project, and the very first project is going to be very easy. And then slowly as we learn, the projects will get harder and harder. So you have to learn to write, learn to use the compiler in the next class. So if you miss the next class, you're going to have trouble. Well, you can of course watch the video. I always record everything and put that video up after the class, so you can watch the video if you missed the class. But it'll be, best to be in class and learn how to use it. Okay, so if you want to have that ready in your computer, or have questions about, if you want to make sure you can download it and install and ask questions about it in class, then you should download it before the class. Okay, so the compiler will be using it in the next class to execute programs. So let's now understand programming environments that we normally have to deal with. Basically, what kind of computers are out there? The microcomputers are the most common ones. They are designed to be computers for individual use, and they are the desktops and laptops. They're all microcomputers. They are basically personal computers designed for one person to use. Uh, so they're good for us, you and me, who just use a computer for our own purposes. But businesses like banks, for example, cannot use microcomputers. So let me explain why. You go to the bank and you see these tellers standing with computer screens in front of them. And if they are using personal computers to do the business, uh, let me explain what the problem will be. You go to one teller and withdraw all your money in the account, then the account balance goes down to zero. But if that information is stored in that personal computer that teller is using, then you can go to another teller and withdraw money from the account that has zero balance, because that other teller doesn't have the current information of your bank balance, and so that teller can end up giving you money when there is zero balance. So that's a big problem. They cannot work with that kind of setup. So that's why the banks use either mini computer or mainframe computer. A mini or mainframe computer allows multiple users to use the same computer. So when you go to the bank, the computer screen that you're seeing and the keyboard you're seeing are not computers. They are just monitors and screen combinations, which are connected to one computer, which is in some other room. That's a mini or mainframe. They're big computers. Mini and mainframe are big ones. They're usually they usually vary from the size of a small refrigerator, or a dome-sized refrigerator, to um, home-sized refrigerator. The large refrigerators. So it's the size of a refrigerator essentially, but it varies in the size. So they normally have a mini or mainframe, and this one computer that's sitting in one room, some room, is connected to all those tellers, and the manager and everybody in that entire building is using one computer using different terminals. And they're all accessing same files that contain balances of the customers and all that. So if one teller changes the balance, that's changed in the mini computer. So another teller will be accessing the new balance from the same computer. So that's the kind of setup they need to use, and that's what they use. So most of the businesses use either mini or mainframe computer, and everybody in that business is accessing the same computer. All right, so going on to supercomputer, the main difference between supercomputer and the other computers would be multiple processes. It has several processes, so it can do parallel processing. Parallel processing means processing many programs at the same time. That's what the supercomputers are capable of. And also, they are designed to produce results that are very accurate. The numbers will be accurate to 30 decimal digits and things like that. So extreme accuracy, if you need that, then you need supercomputer. So one of the agencies that have that would be NASA, because all their computations have to be extremely accurate, and that's why they have that. So this computer is very rare. Only very small number of businesses out there have them because it's not needed. Mini and mainframe are very common among businesses, and personal computers are also common in businesses and personal users like you and me. So that's what the computer systems are, and the kind of program we write, we will be writing, we'll be running them in microcomputers, but they're all good for any other computer as well. The same program can run on mini computer or mainframe. All right, so that finishes section 1.3, and all the problems in 1.3 will be part of the homework. All the yeah, specifically exactly what problems you have to do for the assignment 3 will be clearly specified in the link. That's the most accurate information you'll find about the assignment. Exactly what problems are to be done in that assignment will be clearly stated in the link itself. So you rely on that more than anything else. So I'm going to move on to 2.1, where we will learn more about running program, a writing program, a little more about writing program. Okay, basics of computer programming. So in chapter 1, we learned about the basic ideas involved, basic background knowledge you need, mathematical and basically mathematical background, such as binary coding and octal coding. So that's the basics. Now we are going into computer programming. And in this chapter 2, we'll be learning the basics in computer programming. So we'll be understanding what a variable is. The variable is the very basic key component of any program. And also how to write simple statements and what would be the meanings of statements in computer program. Even though the statements we write in computer program look like mathematical expressions sometimes, they don't always have the same meaning. So slightly different meanings are there for these statements. And so we need to understand those. And also we'll understand how to instruct the computer to do basic arithmetic operations and things like that. So all the basics of computer programming will be done here. So first thing we need to understand is constants and variables. So let's first talk about constants. Constants means basically the data, the information we provide to the system to process. And they are called constants, and they are sometimes part of the program, or they are sometimes stored somewhere else and the computer will have to go and get them. So first we have to understand what they are, the constants. And when we, so let's understand the constants. All the constants or all the data involved in computer programming will be categorized into two. They're called numerical constants and character constants. Numerical constants are basically numbers. Numbers fall into that. Character constants are everything else, the characters. Characters are alphabets in English and symbols we use. Any symbol will be a character. So if you can actually make a numeric character, a number can be used as a character constant. So we need to learn the details of that. So let's look at this 23. 23 is a number, so it falls into the numerical constant. Minus 7.5 is a number, has a fractional part, but still a number. All numbers fall into numerical constants, whether they are whole numbers or fractional, negative, positive, doesn't matter. They're all numerical constants. Character constants are symbol characters like J, symbol one character only. You cannot have multiple characters. Only one character can be used as data, character data, and it will have a single quote around it. So any character that you want to use as a data, you have to put single quotes around it. Only then it will be character data. Now let's understand the numerical constant that computer can accept as a numerical constant would be a number that may contain a plus or minus sign at the front and a decimal point somewhere. That's all you can have. The only characters allowed in a numerical constant would be plus or minus in the front and a decimal point somewhere. No other characters will be allowed. Uh, other characters sometimes we use are commas. When the number is very large, we use commas to separate some digits, and those commas are not allowed in the data that you're using in a computer program. So only characters allowed are plus or minus in the front and a decimal point. So you have to remember that. So let's look at some examples. Before looking at examples, the numerical data types are divided into two: floating point type and integer type. Integer type will be number without decimal point. Any number that has no decimal point, normally in math, integer number means a whole number, right? So in computer science, there's a slightly different definition. A whole number can be integer. Whole number can be float number also, because if you put a decimal point behind it, it's a whole number. There's no fractional part, but it is not integer type in computer science. So if the number has a decimal point anywhere, then it is floating point type. If it has no decimal point, it's integer type. That's the definition for integer and float type in computer science. So here's an example. 23.64 is float type, numerical constant, which is float type. Minus 5 point is numerical constant, which is float type. And integer type will be 34 or minus 4 or integer type. There's no decimal point. So like I said, the decimal point is what makes them different in computer science. Okay, so here's an example. There are questions in that, in your homework, in that topic, of which ones are valid constants and what are the types, and all those you need to be able to identify. 35.72 is a valid numerical constant. It's float, and it is float type. Minus 6.2 is float type. 5 point is float type. And 284-5841 is invalid as a numerical constant because of the dash. This will be invalid as a numerical constant, and it is it cannot be used as a data. You will be learning in 272 how to use a long character string as data. This is called string. That will be coming into the data type called string type, and that's beyond the scope of this class. So in this class, we can only handle numerical constant and character constants. Character constants can have only one character in quotes. This is invalid as a numerical constant. Why? Anybody?
Is it because of the comma?
Because of the comma. If you are writing this in a computer program as a data, then you cannot have the comma. You remove the comma, then it will be fine. Going on to character type data. A character constant is any character in single quotes. So if you put single quotes around anything, any single character, it'll become a character constant. So that means R, capital R with the single quotes around is a character constant. Lowercase r, even 7 with the quotes around is a character constant. If you write without the quotes, it's a number, numerical constant. Slash with the quotes around is character constant. M is invalid character constant because it doesn't have quotes around it. 7 is valid numerical constant, but invalid character constant because of the missing quotes. So summary of data types. Data types, three kinds of data types we have learned. Floating point type will be number with decimal point. Integer type will be number without decimal point. Character will be single characters with quotes around them. Three types of data. You'll be learning more data types later. Right now we have learned the basic data types. And some of your homework questions will ask you to identify the data types. So you need to know what they are. In order to process data in the computer, we must first instruct the system to store the data in the internal memory. This is the computer program. The idea of computers were, originally it's a result of, the computer is a result of humans' attempt to recreate human brain in a machine. They haven't done it yet, that's still, research is still going on. But this is, the computer that we are using is a partial success of that attempt. So basically it uses the idea in the way, the way the human brain works. It's the idea of how the human brain works is kind of mimicked in this machine to some extent. And so the computer program is based on the same idea how our brain works. So think about adding two numbers. Adding two numbers is a very basic programming task. We will write that as our first program. So let's think about the steps involved. So let's say I'm asking, I want to put down two numbers on a piece of paper, and I want to give it to you to add. So if I give you a piece of paper with two numbers written on it, like these, 23, okay, let me try again. So I write 23 and 7, two numbers on a piece of paper, and I say, I give you the paper. You're looking at it on the board, but let's say I give it to you on some paper and ask you to add those two numbers. The numbers are there on the paper, and I'm asking you to add them in your head and give me the answer. So you are going to add them in your head. What are the steps? Think about the steps that you're going through to do this task. What is the very first thing you're doing? When I give you the piece of paper, what do you do first? Anybody?
You said we don't write it down?
I already wrote it down on a piece of paper and give it to you. I gave it to you. You're now looking at the paper. What are you doing first?
I would personally, I would put, I'd make sure that it's addition. So I put my plus sign there between the 23 and 7, right? So I put 23 plus 7. Then at the end of the 7, put an equal sign, and then write my answer. That's what I would do.
Okay, but yeah, I understand. But my question is, you're adding these numbers in your head. So
That's the information first.
you are reading the information first. Exactly. That's the step. Those are the steps I'm asking. The very first thing you're doing is you're reading those numbers into your memory, right? They're going into your memory. And what is the next step?
You're adding the numbers.
Exactly. You're adding them in your head, in your brain. You're adding them in your head. When you're adding them in your head, you're adding them and putting the answer in your memory also, right? The answer is also going into your memory. Now you have 30 in your memory somewhere. Agree with that?
Yeah.
Okay, now you have the 30 in your memory somewhere. What is the next step?
You write it down.
Either write down or tell me. I told you to do this, so you're going to tell me the answer, or you're going to write the answer on the board. Like the other student said, you put an equal sign and write the answer. That now you're presenting the answer. These are the steps. These are the exact steps that we had to write in our program to write a computer program to do the same work. We need to say store 23 in a memory and then store 7 in a memory, 2 different memory. Then we had to say add the 2 memory cells, put the answer in another memory, right? So same way our brain works. Put the answer in some memory. Then we have to say, tell us what is in that other memory. Agree with that? These are the exact steps we need to write to tell the computer to do this work. It's the exact same steps that the human brain will be using. So the first step is to say store 23 and store 7 in 2 memory cells. And that part, how do we say that? That is where the variable names come in. Variable name is a name you make up that will become name for the memory. You choose any name, and as soon as you use it in your program to write a statement using that name, it automatically becomes name of a memory cell.
I have a question.
Go ahead.
So the variable thing, right? It's like X and Y and A or B, like a variable like that.
Yes, you can use X and Y, or multiple letter names like num, val, any name. There are some rules that you had to follow, but it pretty much allows any name. So to store the number 23 in the memory cell, I need to write an instruction, right? The instruction to say store 23 in the memory cell will involve making up a name. So let me say I make up the name num, and when I write num equal to 23, this is a C++ statement, and here is what it means. It means find the next available memory cell and name it as num. So it'll find the memory cell. I'm using this box to identify memory cell. It'll name it as num. And then it also says store 23 in it. So it'll store 23 in it. All that is said in this statement. So this is called an assignment statement. And this name refers to a memory cell. It'll become a name of the memory cell automatically, and 23 will go in that memory cell. All that is done by that statement. So, like I said, we are trying to mimic the way human brain works. And so we need to tell the system to store these numbers in the memory first, and that will be done by this. So if I want to say store 7 in a memory cell, I don't want to write num equal to 7 now. Why? Why is this wrong?
Because you can only store one number in one memory cell?
Yes, you can only put one number in one memory cell. So that if you write num equal to 7, after writing num equal to 23, then you're saying, so erase the 23 and put 7 in that memory cell. That's what this means. Erase 23 and put 7. We don't want to do that. So all you have to do is make up a different name, like rate. Okay, so if I say rate equal to 7 and put semicolon behind it, the semicolon indicates end of the instruction. If there's no semicolon, then compiler will complain because it won't be able to translate it. So you need to put semicolon behind every instruction. And we write each instruction one per line. We don't write, even though if you write everything in one line, it will understand it, compiler will understand it, but human readers will have trouble reading it. So you're expected to write one instruction per line. So I wrote num equal to 23, and then I wrote rate equal to 7 in another line. And what does that mean? The second one, what does that do? It'll find the next available memory cell, name it as rate, and it'll put 7 in it. The number 7 will go in that memory cell. So we have stored 2 numbers in 2 memory cells. That's what we have done so far. So to store each number in the memory cell, you just have to make up another name and assign that number to that name. It's called assignment statement, but it really stores the value in the actual memory. So this is how we access the memory. We create a name and assign your data to that name, then you are accessing the memory, next available memory. So in this particular example, I'm writing num equal to 23. We are storing 23 in one memory cell and storing 35 in another memory cell called rate. And so after writing rate equal to 35, if I write rate equal to 54, then I'll be replacing the 35 with 54 because only one number can stay there. So you don't want to write that rate equal to 54. It'll be replacing the value. Also, if you write rate equal to val, a variable equal to another variable, that would mean copy the value of val into rate. So rate equal to val means semicolon. Every instruction will have semicolon at the end. It means copy the val into rate. Always assignment goes this way. Like here, num equal to 23, 23 goes into num this way. Always, that's the direction of the assignment. You have to remember that. If you write val equal to rate, then you're copying the opposite direction. So this will copy val into rate. So if, let's say we have these three statements in a program, num equal to 23, rate equal to 7, and then rate equal to val. Now, what do you have in the memory cells now? What do you have in num now and rate now after these statements? Do we still have 23 in num?
Yes, I think
Yes,
so.
it didn't change num. So 23 will be still there. What do we have in rate?
Val.
Would it be 23?
It'll be 23. This statement rate equal to val means copy the value of this memory into this, not the word val. Every name represents memory. It knows that, system knows that. So the val refers to a name, so it knows val is a memory cell. And so this statement means copy the value of the memory cell val into rate. And so therefore, what is copied into rate?
So it's still 7.
23.
But
Oh, I'm sorry, val, I use the rate. I don't have a val, sorry about that. Let's say rate equal to num. That's what I meant to write. Okay.
so now it's 23.
So rate equal to num. So what do I have in rate now?
23.
23.
Because I copied num into rate means value of num will be copied. So now I have 23 in both. If that's what you want to do, you do that. But
I have a question.
sure.
So if you put the semicolon where rate is, will it make it so that val is equal to rate instead of the other way around? Or does that not matter?
If I write val, I didn't use val anywhere here, right?
I mean, num. Yeah, I meant if you put the semicolon where rate is instead of where it is on num, is it going to change what equals what, or is it just going to stay the same?
I didn't follow that question. So if are you changing the rate equal to num to the other way around, num equal to rate?
Just the semicolon. That's the only difference.
The
Put it on.
semicolon, yeah,
Yeah.
the semicolon has to be there. If it is not there, system will not understand this as an instruction. So a compiler will complain about that. It's just a syntax error if the semicolon is missing. Okay.
Okay. Okay.
So, Professor, sorry.
Yeah.
The semicolon just has to be at the end of every statement
At
then,
the
right?
end of every statement, the semicolon must be there. Yes.
Okay.
So if it is not there, what it will do, if that was the question of the previous student, if it is not there, nothing will be done. The compiler will not process your program. So it's a syntax error. So nothing will be done, okay? Syntactically, your program must be right before it can be executed. And one of the syntax is semicolon at the end of every statement. So that must be always there. Writing one statement or one instruction per line is a rule for the human readers because it's easier for you to read when you read your program if they are written one per line. So that's why we do that. Okay, so how do we then write the program that will add two numbers? Simply these, num equal to 23. So if I just say num equal to 23, then I'm storing 23 in a memory cell called num. Rate equal to 35, storing 35 in the memory cell called rate. Then I can write num plus rate to add the memory cell num and rate. The value stored in the variable num and the rate will be added. So plus symbol stands for addition, the same way as in math. And then I have to assign it, this equal sign means assignment, to another variable name, because we had to put the answer in another name. So if you write sum equal to num plus rate, it'll add up num and rate and store the result in sum. Now remember, the sum equal to num plus rate has to be written in this order. If you write num plus rate equal to sum the opposite way, that'll be wrong. The compiler will not compile your program because it's not understood. On the left side, you can only have a variable name. On the right side, you can have any expression. This expression is just addition, but you can have subtraction, division, or even multiple operations can be there on the right side. Only on the right side. Left side can only be a variable name because the assignment goes in this direction. From the value of this will be stored here. That's how it goes. So now we have written a program that will add two numbers and it'll have the answer in the variable sum. So what is remaining is to get the value of sum displayed on the screen, right? If you do that, then we'll have our program ready. So the instruction to put the answer on the screen or on the paper is what we are missing. We'll get to that. But there are also some other formal statements, such as variable declarations we need to learn how to do to finish the program. We'll be discussing all that later. So let's proceed to understand some more operations. Just like the plus does the addition, the multiplication will be asterisk. The reason for using asterisk is because if you allow the cross symbol, the multiplication symbol, it will. There are two problems. One is the keyboard doesn't support this symbol. In math, word processor has that symbol, but the keyboard doesn't support it. We are not using word processor, so a keyboard has to support everything we write in C++. Another reason for not using this cross symbol is it resembles X, so it can be mixed up. And we cannot allow any kind of confusion anywhere. So that's why they adopted asterisk for multiplication instead of cross symbol. Slash for division. So if you need to divide, slash is what you need to do. So here's an example. If I want to say divide the value of num by val and put the result in ands, that's what this instruction says. Divide and put the answer in the ands. And if I want to square the value of num and put the result in ands, I can only do num times num. There is no exponent in C++. There are ways to handle large exponents that'll be coming up much later in the course. Near the end of the course, we will be learning those ideas because they are not built into the language. They are coming from other means. So they cannot, so basically what you have to remember is there's no exponent. Only way to get square is to multiply twice. If you want cube, num times num times num. you only need basic exponents at this point. So if you need larger exponents, we'll be learning how to handle that later. The language itself doesn't have exponents. So num times num and equal to num times num means put the square of num in ands. Okay, the variable name, I have been using 3-letter variable names, but variable name can be single letter, like this, n equal to 9, semicolon. That says store 9 in a memory cell and call it n. It's valid. Okay, so these are the assignment statements. These are called assignment statements. They are storing value in memory cells. So any statement that has an equal sign is assignment statement. In an assignment statement, you will have a variable on the left and an equal sign, and then a constant or variable or expression on the right side. You can have anything on the right side, but the left side can only be a name. Now, imagine this assignment, num equal to num. What does it do? It copies num into num. There's no purpose of that, right? It's valid statement, but why would you write that? You know, just it's basically a dummy statement. It's not really achieving anything. But believe it or not, some of you will be writing it in the homework. I'll point it out when you do it. But you know, it's a crazy idea, but some students tend to write it in the program. But you know, that's why I'm explaining. You never need this statement anywhere, so don't write it.
Professor?
Yeah.
Are you ever able to put like the sum of two numbers, or it has to have a variable?
Oh, okay, good question. Can I write sum, that's your question, I believe, sum equal to 23 plus 7? Is that the question? Yes.
Yes.
Okay. Yeah, very good question. Well, if you write it, you basically, you know, you're prohibited from writing this way. But if you actually write it, the compiler will take care of the details. It will store 23 in a memory cell, and then it'll rewrite a statement for you. It'll rewrite a statement of storing 23 in a memory cell, and then storing 7 in a memory cell, and then adding those memory cells and put the result in sum. The compiler will do that job, and it'll accept it. But you know, then you're giving more work to the compiler. There's no reason to do that. So you shouldn't do that. You shouldn't write this. You should not write it this way. You should always every individual number you're using in the program should go into a memory cell first. So you must write the program the way I have explained to you here. Num equal to 23, and then rate equal to 7, and then sum equal to num plus rate. That's how you should write it. Even though this will work, this is not acceptable. You should not write it this way. Okay.
Okay, thank you.
Thank you for that question. That was definitely something I needed to say. All right, so let's think about some exercises here. If I, to multiply three numbers, 25, 32, and 62 together, go ahead and write the statements. Okay, when you have it ready, you can show it to me by putting it against the camera. you had to turn the video on and put it against the camera. All of you have the camera turned off. It's okay to have the camera turned off, but if you have the answer, I like to see it. You're all muted, so if anybody wants to talk, you have to unmute yourself. All right, I see one answer from a student. Okay, basically they're right, except that each instruction must have semicolon behind it. You don't have that.
Like after A, B, and C. Got it. Yeah.
Individually, each one
Yeah.
must have some. Okay, you don't have them, but other than that, that's right. Very good. Okay, put semicolon behind A equal to 25. Right after the 25, you need semicolon. Okay, I'm seeing Christian's solution. Bring it down a little bit. Okay, I see it now. Right. Very good. You got it. Okay, 2 students have right answer. Vanessa, you understand the problem, right? You need to put semicolon behind every statement.
Copy. I understand. Thank you. Sorry.
All right. I have seen 2 students' solutions. They're right. Anybody else? Okay. I'm pretty sure most of you got it, but you don't want to turn the camera on. That's fine. So I'm going to write them. I'm going to write the answer for the first one. Basically, you need to just make up names for the 3 numbers to be stored. So let me use A equal to 25, semicolon. You need to write 1 instruction per line. So A equal to 25 is 1 instruction right there. I write B equal to 32, semicolon. C equal to 62, semicolon. Now to put the answer, I can make the variable ans equal to A times B times C, semicolon. Right there, that's the program. There will be a
question.
Yeah.
If we write it across, does it still like affect the problem, or is it like still the same answer, or do you prefer this way? Like if you write like A instead of making it 1 row, instead of making it like 3 different rows.
It'll work if you put them all in 1 row.
Okay.
But as a rule for programmers, we have this rule that you write 1 instruction per line.
Okay.
So that others can read it easily.
All right, thank you.
Warm-up exercise 2 says write C++ statement to double the content of the memory cell named val. Okay, so it means, indirectly it means val has a number already and we don't know what it is. Okay, so here's the memory cell called val and there is some number, we don't know what it is. So let's say I have a 7. So the statement you write will have to replace this with 14, okay? But you don't know what value there is. 7 is just an example. So whatever the value there is, your statement will have to replace with double of the original value. Okay, I hope you understand the problem. The value of the val should be replaced with twice the original value, and we don't know what value is there. Okay, let me see if you can write that. This is what computer programming is all about. You know, you have to come up with the right way to achieve your task.
So for val, can we just put any number to like, we can just put any number? Or
No,
does it have to?
You cannot make up any number. Val already has a number, and that number should be doubled.
Okay.
Okay, we don't know what it is. You cannot make up a number. Val already has some number. We don't know what it is, and that number should be doubled. If you have an answer, put it against the camera. I'll see it. Okay, I see Vanessa's solution. Sum equal to Alexandra, Vanessa, both of you have same wrong statement for the last line. Basically, you're doing the multiplication, but you're putting the answer in some other memory. So that's like this. Your val has 7, you are taking double of that and putting it somewhere else. Some other name has the 14. That's not good enough. The new number should replace the 7. Okay, I see Gabriel. I think you have wording in the wrong way. You're showing it the wrong way. Can you turn it sideways, Gabriel? All right, now we can see it. But plus, okay, yes, Gabriel got it. Yep, you got it. Gabriel has the right answer, and Alexandra has the right answer now. Very good, very good. Okay, you're right. Gabriel and Alexandra have the right answers. Anybody else?
Is it because I put sum? It's not supposed to be sum. It's supposed to be the new value of val. Is that what that is?
Yes. You cannot use a different. If you use a different variable like sum, then you're putting it in another memory. But we need to replace the val itself with 14. It had a 7 before. Now it has to have 14, right? You have a better.
Yeah, I get it.
Okay. Anybody else has an answer? Okay, I'll proceed. But only 3 students participated in that question. You know, you should try to participate. If you participate more, you learn more. You learn a lot. And, you know, also it goes into your memory better if you participate. So I strongly advise you to try and participate in the class discussion. So let me explain this problem. Val has some number in it, we don't know what it is, and we need to replace with the double. And very common, some answers, some students wrote something like this. They took the val and multiplied by 2. You can multiply by 2. The 2 doesn't have to go into a memory. The 2 is something, you know, you're introducing. It's not a data. Only data have to go into memory cells. 2 is not a data. So we are multiplying val by 2. And if you put that in sum, this was common. A couple of students gave me this as answer. What's wrong with that? Val times 2 is calculated, double the value, but it's stored in another variable. So you're storing in another variable sum, the value 14. But the problem says you need to replace the val itself with 14. The 7 should be replaced with 14. So what is the right way? This is the wrong way. You need to take val and multiply by 2, put the result back in val. Then you are replacing val with double of this value. I know this mathematically, this looks wrong. This is invalid equation. But it's not mathematical equation. It's an assignment statement. That is very commonly the problem. Students try to associate these statements to mathematical equations. Mathematical equations are different. These are assignment statements in computer program. So this is the right answer. Val equal to val times 2. Or also another student wrote it this way, val equal to val plus val. That is correct too. Take val and add the same value. That's same as doubling. That's another correct answer. There are more than one correct answer to computer programming. Okay, so that we'll stop here. We're out of time. I strongly advise you to try these warm-up exercises 3 and 4 at home before the next class. The number 4 is challenging. I strongly advise you to try these before next class. Then you will be learning better in the next class. So I will quit here, and remember we'll be doing programming in class, next class, and you need to be there to be able to understand how to run a program, because after that you'll be doing programming projects on your own, and you'll be running them on your own and produce answers. The tutor is setting up meeting every Thursday. And last Thursday, he had a meeting set up and he sent you the information, the meeting link and everything. He'll continue to do that. And also, if you need to contact him for help with any homework question, you can do that. Feel free to contact him. And I have office hours at 2 o'clock Mondays and Wednesdays. I will have one today also. You can meet with me if you have any questions there. All right, enjoy the rest of the day. I will see you Wednesday.